Okay, so the ideal gas law, all right? Big idea, we're going to put it up at the very top, is we're going to just write it out saying PV equals nRT. Okay, PV equals nRT. Okay, and so what this little gas law is it's the combined or direct relationship between all our variables that we've seen before. So it's the combined and I'm going to say direct relationship between pressure, volume, temperature, and the number of moles of gas. Okay. Okay, then it's just having you write the little equation again. So once again, we're going to see PV equals nRT, and we know that we can rearrange this however we need it to be, right? So if we were trying to solve for, say, temperature, how would we arrange that? Who needs to move to the other side in order to solve for temperature? No. Who needs to move to the other side? Yes. The N and the R. Do you guys see that? We want to get temperature by itself, so we need to move the other guys over. So it's going to be PV over NR. Do you guys kind of see that? So when you're trying to solve for one of those variables, you move the other guys over, the other guy over, okay? So once again, if we're solving for, let's say, volume, who has to move over from the original equation? The P does, right? So it's going to be nRT all over P, okay? So once again, when you're solving for something, you move the other one over, okay? All right. So this big law has the little special R. R is going to be a constant. Okay? And it says that the volume of a gas varies directly and just a reminder, what does directly mean? If one goes up, the other goes up, right? Okay, so just remember that relationship. With the number of moles of a gas and what temperature? What unit do we always use for temperature? Kelvin, okay? It'd be super important that you're not forgetting that one. That is not Kelvin, it is Kelvin, just so we're clear. All good? All right. Okay, and it also, that the volume of the gas is going to vary inversely with who? Who is it next to in the equation? Who? Pressure, exactly. Okay. So just a reminder of what we kind of talked about when we did the POGL back when, was that when you want this direct relationship, remember you're on both sides of the equal sign. When you have something that's inversely related, you're usually both on the same side. Okay, and that's an easy way to look at any of your formulas out there, and you can figure that out, okay? The other way was when it's directly, you have something that's on top of the other, and this one, they're obviously just going to be next to each other, okay? So don't forget those ways to just look at a formula and know what are those relationships so that you don't have to sit there and memorize millions of things, okay? All right. So let's talk about this ideal gas constant. Does everybody have a periodic table in front of them? Go ahead and open it up to our ideal gas constant so we're not sitting there looking. Okay? So the ideal gas constant is our letter R. Okay? And the type of R that we use depends on what? What is the only difference between all those numbers? Say that again. What it's multiplied by at the top. So but what are those units that are changing? What are those measurements of? Pressure, right, okay? So it always depends on the pressure chosen. So knowing that, the way you're going to approach all of your problems is you're going to look at it. If it is not one where it says you have a certain volume, certain temperature, but now I'm going to change the temperature, what happens to the volume? That was a before and after. That's what we've been doing, okay? Now what we're going to look at is we're going to say, hey, you have this volume, this pressure, this number of moles. I'm sorry. You have this volume, this number of moles, this temperature. What is the pressure? Did you notice there's no before and after? It's just a straight, hey, what is it? That is when you know it's ideal gas law. The minute you know that, you look for pressure. You have to go look and see what unit was either given to you or what unit they're wanting, okay? So as soon as we go to look at the problems down below, that's what you need to be doing. All right, so let's go ahead and write out our different R's. So one of the R's, let's start with kilopascals. What is that R going to be? Huh? 8.31, good. 8.31, and I am going to write the units, at least for these, okay? So, is it, I'm not going to talk and write, hold on. All right, so as you notice, we have liters and we have Kelvin, okay? It's going to be the most important thing that you make sure you take care of, kind of like our lab. So all the stuff that you did on your lab was ideal gas law. It was all rearranged in different ways, but it was all ideal gas law. So everything that you did in your lab, all the mistakes that we made were, oh, we weren't in liters. Oh, we weren't in this. Oh, we chose the wrong R. Those are the things you have to pay attention to now, okay? All right, the next one, we have atmospheres. What's that one? Good, 0.0821. Let me make a little decimal there. All right, so this is, in AP, we call it lattimolk. That's usually what they use. Okay, but it's liters, ATM, moles, Kelvin. So once again, we're still sticking with that liters and Kelvin. Okay. Finally, we've got our last guy who is either torr or we'll see millimeter mercury. And that one will be what? Good, that's the one that we used in our lab. So we got 62.4. Am I still on the screen? Okay. And he is going to be using liters times that millimeter mercury or whatever all over mole Kelvin. Okay? Okay. So take a second and look at the units again. What is that? What is liters? Volume. What is kPa? So that's PV over what's moles? N. What's Kelvin? Temperature, right? So this is PV over NT. Have we been using that? Yeah, that was our combined gas law. Okay. So once again, everything that you see in this little part of this unit, it's all the combined gas law, just not combined gas law, sorry. Ideal gas law rearranged. Okay. If I were you, I would circle the liters so that you know that that's going to have to happen. Okay. I think a lot of you guys have gotten used to the Kelvin part, but if you need to remind yourself on that, make sure you circle that one too. Okay, cool. So now, I think I covered everything I wanted right there. Let's go ahead and start looking at our problem. Okay. All right, so the first problem says, what is the pressure in atmospheres exerted by a 0.5 mole sample of nitrogen gas in a 10-liter container at 298 K? Did you see that that was a whole bunch of facts? Did it say I changed something or I increased or I decreased anything? No. So this is when you know that's ideal gas law. It's talking about one situation, okay? So what was the first thing you got to look for? What? Pressure. All right, I see the word pressure here. It says in atmosphere. So automatically, I know the R I want to use is what? Good. 0.0821. I'm so sorry that that's showing up. I don't know how to make it go away. Nope. Yes? Maybe? Okay. All right. Exerted by a 0.5 mole. So what is the mole variable? N. Okay. And I should be putting my little units on these, at least for my list. When you go to show your work, you don't have to put them in there. Okay. And then nitrogen gas. So it's going to be important soon, not necessarily for this one, but what does nitrogen gas look like? What is it? What's the formula? I'm hearing. And what? N2. Good. All right. You guys are saying it super quiet. All right, N2. So it's going to be important because we're in gases. You got to know all your diatomics. Those guys tend to be your diatomics, okay? And when we get to stoichiometry, that's where it's going to be super, super important. So we got a sample of nitrogen gas and a 10-liter container. So that's just our volume. And it's at 298 K. So do we have to convert anything? No, those are your favorites. Okay, awesome. So we've got all this. We know that we want pressure. Okay, so we're just going to set up our ideal gas law. I'm going to say PV equals nRT. You are totally allowed to just plug your things in and solve for it if it makes it friendlier on your eyes. But I'm going to practice with y'all rearranging it. So if I'm solving for P, who needs to move over? The V does. All right, so we're going to rearrange this now to be P equals nRT all over V. And now I'm going to plug in everything, so it's all ready to go. Okay, so I have P is equal to, if you're trying to do it in one step, make sure you use those parentheses. It's very important. You cannot skip that. Divided by 10. Okay, and remember, if you had multiple things on the bottom, you're going to have to multiply it in parentheses. Okay, go ahead and do that. See what you get. Once you've got it, shout it out and we'll second it. All right, so we've got 1.22. What are my atmosphere? There you go. There's your unit. Atmospheres. And you're done. Okay? So I want you guys to try letter C on your own, and then we'll check it. Okay, so after plugging all of this in, we get 0.30 moles. Okay. If you are not getting that answer, biggest mistake is you are typing in the top line and then you're just you're saying divide and then you try to multiply it without using parentheses. Make sure if you're trying to do it all in one step, you've got to put parentheses on the bottom. Okay? I would say that is the big, and parentheses on the top actually. Okay? Did you guys hear her question? She asked, does it matter which one ends up on top? Like, you know how in the last thing when we were doing Charles' Law, I said, oh, you can put temperature on top and volume on the bottom if you want. You can't do that with ideal gas law. It's a specific ratio that keeps certain things direct relationship and other things inverse. Okay? Okay. Okay, so this one's my favorite one. I just want you to write it at the top, and then we're gonna talk about it. So you've already actually done this equation, but the way to kind of memorize it, because this one usually isn't given to you, is I want you to put meow equals dirt over pee, because when cats go to the bathroom, they put dirt over their pee. Yeah, that's cool. The one that you used, okay, replace this D. It was density. What is density? What do we know density is? It's over there. Over there. Blue poster. What is it?
M over D.
No. M over volume. It's mass over volume. So what you guys did in your lab was you changed it to mass over volume times that RT over P. So you had MRT over PV. If you remember that one, that was one of the third one. I think it was the third one, okay? So you're going to be using this, but I wanted you to know where it's coming from, and we'll talk about it tomorrow.